let's talk about balancing equations. One thing to keep in mind with balancing equations is that whatever you start with in terms of atoms and amounts of atoms has to be what you end with. So we're going to be comparing the reactants to the products and changing the coefficients in order to balance. All right, the way I like to approach problems when it comes to balancing is I draw a nice big fat line through my arrow, because to me that just separates my reactants from my products so that I don't confuse the two and I can keep them separate. All right, so looking at our reactant side, we have 1 aluminum. Whenever you do not have a number in the subscript or in the coefficient, 1 is assumed. Now we need to look over at our products and see how many we have here. According to our subscript, which is a smaller number, and our coefficients, we have 2 aluminums. Because the reactant side is less, I'm going to change the number on the reactant side. So if I put a 2 in the coefficient spot, 2 times what is assumed to be 1 in the subscript is 2. So now I have 2 aluminums on both sides. That is balanced. And now we move on to oxygen. On the reactant side, I have 2 oxygens, and over here I have 3 oxygens. Because we can't use decimals or fractions, I can't multiply 2 by anything to get 3. So therefore, I'm going to have to think about the first number that they have in common, which is 6. So in order to get this oxygen to 6, I'm going to put a 3 in the coefficient spot. 3 in the coefficient times 2 in the subscript gives me 6 oxygens. On this side, I have 3 in the subscript. 2 times 3 gives me 6, so I'm going to put 2 in the coefficient spot. So now my oxygen count is balanced, but by putting this 2 in the coefficient in front of aluminum, I've now changed my number of aluminum. On the product side, I now have 4 aluminums. So I need to go back over to my reactant side, and I need to start over with this coefficient. In order to get 4, and again we're assuming that there's 1 there since there's no number, I'm going to put a 4. 4 times 1 is 4. And now I have a balanced equation. 4 aluminums on the reactant side, 2 times 2 is 4 aluminums on the product side. 6 oxygens on the reactants, 2 times 3 is 6 oxygens on the reactant side. Okay, so this has a significant amount more elements in it. And I want to draw your attention to the polyatomic ions. Polyatomic ions, if they're intact on both sides, which they are, my SO4 is not split up, I can count that as a single unit. And that's going to save you a little bit of time. If what I'm about to do confuses you, by all means, just count them element by element. So count all the sulfurs and then all the oxygens. So let's start by drawing our line, separating reactants from products. I have 1 sodium on my reactant side and 2 on my product side. So I'm going to go to the lesser side, and I'm going to put 2 because it'd be 2 times 1 in the subscript. Gives me 2 sodiums. So my sodiums are now balanced. I'm going to move on to the next element, which is chlorine. I have now 2 chlorines. Keep in mind that your coefficient applies to all the elements that come after it in the compound. So I not only have 2 sodiums, but I also have 2 chlorines. Looking on the product side, I only have 1 chlorine. So I'm going to put a 2 in the coefficient spot here. So now I have 2 chlorines on the product side and 2 chlorines on the reactant side. Moving along to the next element, hydrogen. I have 2 hydrogens on the reactant side, and I now have 2 hydrogens on the product side, so that's balanced. All right, let's look at that sulfate. On polyatomic ions, if you had more than 1 polyatomic ion, you would see it written in parentheses, and you'd see some number down here in the subscript. Because I don't have parentheses, I am assuming I have 1 sulfate molecule. There is no number in the coefficient, so we assume that that's 1, so I still have 1 sulfate. On the product side, I have no parentheses, so no number out here in the subscript, and no number in the coefficient means I also have 1 sulfate. So this equation is balanced. Okay, so this is what an answer would look like. 2 sodium chlorides plus 2 sulfuric acid form sodium sulfate and hydrochloric acid. Alright, this is a combustion reaction. They tend to be the more difficult ones to balance because you have oxygens in two different positions. So I always like to save oxygen for the end, and then I look at the products and go back to the reactants. So I'm going to show you how to do that. We have 2 carbons on the reactant side, and we have 1 carbon on the product side. So if I put a 2 in front of that, 2 times 1 is 2. So my carbons are balanced. I have 6 hydrogens, and here I have 2. If I put a 3 in the coefficient spot, 3 times 2 gives me 6 hydrogens on the product side and on the reactant side. Alright, so let's take a look at what we have going on the product side first. According to my coefficients in my subscript, I have 4 oxygens here, and these 2 compounds are separated by a plus sign, so I'm going to add them together too. I also have 3 times 1 is 3 oxygen here. So on the product side, I have a total of 7 oxygens. This is not good because I have 2 oxygens on the reactant side. So no matter what I multiply this 2 by, I'm not going to get an odd number. So what I'm going to do is I'm going to go ahead and increase this coefficient on water to the next number. So since I'm going up by 3s, I'm going to go ahead and add another 3 and increase this to 6. Okay, so before we get too far along, let's go ahead and add up what's going on with our hydrogens. So I have now 12 hydrogens. I'm going to go back to my other side. I've changed everything. It's a mess. And I only have 6 hydrogens. Well, 6 times 2 gives me 12. So now I have 12 hydrogens. And of course, that 2 applies also to the carbon. I've changed that. It is now at 4. So I go back to my product side. This will have to change to 4 as well, because 4 times 1 is 4. And now all elements except for oxygen are balanced again, and I'm going to see if this works out. So I still have 4 oxygens. Oh, I do not still have 4 oxygens. I now have 4 times 2 is 8 oxygens with my carbon dioxide, and 6 times 1 is 6. So I now have a total of 14 oxygens on the product side. This is awesome. It's an even number. I can work with this because 14 divided by 2 gives me 7. So I am going to use that knowledge to put that in my coefficient spot. So 7 times 2 is 14 oxygens on both sides, and your problem is now balanced. Whoops. All right, let's go ahead and draw our line through here. And let's look at phosphorus. I have 1 phosphorus on this side, and I have 2 phosphorus on the product side. So I'm going to go to the lesser side. 2 times 1 gives me 2 phosphorus now on this side. So we're now balanced with our phosphorus. I have 2 oxygens on the product side, and I have 5 oxygens on the product side. Sorry, reactant side, product side. I know that no matter what I multiply that 2 in the subscript by, I'm going to wind up with an even number. So the easiest way to make this odd number on the product side turn even is to multiply that compound by 2. So now I'm dealing with 10 oxygens. 10 can be divided by 2. You get 5. So that's what I'm going to put in the coefficient right here on my reactant side. So now I'm up to 10 oxygens on both sides. By changing this coefficient in front of phosphorus, I also change the number of phosphorus to 4. 2 times 2 is 4. So I need to go back to my reactant side and change this coefficient to 4 as well, because 4 times 1 will give me a total of 4 phosphorus.